Hello everyone. Today, I'll introduce the project from Group Q about Dialpad. I will introduce this project in 5 aspects. Today's digital security issues have become the focus of global attention, as well as problems such as password leakage and account theft have become more and more frequent. During attacks, shoulder surfing and thermal attacks are frequently employed. Therefore, improving the security of password input is very important for protecting the user's privacy. To solve this problem, we have designed a new type of mobile phone password input keypad based on the old-fashioned telephone dial pad, called Dialpad. The code disk is designed as a circular turntable, as well as the 10 digits from 0 to 9 and an input digit are arranged on the outer circle of the turntable. As the user selects numbers to transfer them to the input position, all other numbers on the dial are blurred. When input is successful or abandoned, the numbers are returned to clarity and the disk rotates. The following experiments will demonstrate that Dialpad is more effective in protecting against shoulder surfing and thermal attacks than the traditional 9-key digital password pad. In order to verify that the Dialpad is effective against shoulder surfing and thermal attacks, we set up a controlled experiment to analyze the optimization effect between Dialpad and the traditional keyboard. In order to quantitatively analyze the results, we set 3 dependent variables as the basis for calculating the attack success rate. The experiment began with 2 shoulder surfing attackers standing 50 centimeters behind the user on the left and right. As a paper prototype was used for the test, a staff member performed the page switching instead of a physical phone. 2 staff members carried out cryptographic guessing of the results records and 1 member carried out a thermal attack. As we can see, the user starts entering the password after entering the username. This was first entered via the traditional 9-key keyboard and then via the Dialpad. 2 separate entries with different passwords. During Dialpad input, the user selects the number and turns it into the input position, and then he can continue to input the next number while the disk is rotating back, without having to wait for the disk to fully reset. At the end of the experiment, the data was processed for 4 aspects: password guessing accuracy, password input time, shoulder surfing guessing experience, and hot track comparison, and conclusions were drawn from the data analysis. Through experimental verification, we can conclude that Dialpad reduces the success rate of both shoulder surfing and thermal attacks. In terms of defending against shoulder surfing, Dialpad was able to successfully reduce the success rate of the attack by interfering with the vision of the shoulder surfing attacker. In terms of thermal attacks, the thermal attacker was only able to observe repeated digit input trajectories due to the random position of each digit resting in the turntable, making it more difficult to guess the digit. However, the time spent entering passwords was significantly increased by the subject's first exposure to the Dialpad and also by the fact that the paper prototype was more difficult to manipulate compared to mobile phone input. Throughout the experiment, we tried multiple versions of the paper prototype through continuous testing and we gained insight into the prototype iteration process. At the same time, there were some challenges in the experiment. For the first one, the low fidelity and high friction of the paper prototype made the subject's operation less smooth, which in turn led to an increase in password entry time. For the second one, as the paper prototype, some features were not fully implemented, such as number blurring, turntable gyration, etc., which reduced the usability of the Dialpad. The implementation of these features would be superior to the current model in real-world usage scenarios. For the third one, the experiment only collected a small sample size, resulting in the inability to extrapolate from this data to all members of the public. For the last one, the duration spent entering passwords was calculated through manual video backtracking, which results in data deviation and undermines the absolute accuracy of the conclusions. This project is the joint effort of these team members. The above is all the introduction to the Dialpad. Thank you for listening.